Hi guys, I hope you are fine. Me too, I'm fine. Guys, today I have decided to do some revision on trigonometry identities. So here I have some question and answers, and guys, we do some revision. So the first thing guys we do is this question 1. Prove the identities. We have 1 plus cot squared theta all over 1 plus tan squared theta equals to cot squared theta. So the first thing guys is that you come and write this in terms of sine and cos. If you write that, you'll get cos squared theta all over sine squared theta. All over, this one is an identity of which it is 1 plus tan squared theta is usually equals to sec squared theta. So after that guys, you come and say equals to, you press this one and cos squared under the same denominator. If you do that, you'll get that all over the sec squared theta. From there guys, we can be able now to cancel the numerator because this one is now going to be 1. And then like here, it's going to be 1. Then you are left with the sine squared theta 1 over cos squared theta. So this cos is going to go up, and this is where I have shown you how it goes up, and this sine squared is left as denominator. So this one we cancel, and finally we have something like this. So this one is cos squared theta over sine squared theta is the reciprocal of tan. The reciprocal of tan is supposed to be cot squared theta. So that's how we get that. Let's go to the next one guys. We are proving the identities. Tan A plus tan B equals to sine A plus B all over cos A cos B. So the first thing we write in terms of sine and cos. For tan A is sine A all over cos A. For tan B is sine B all over cos B. From there now guys, we work with this as a fraction. So you find B is cos A cos B. So you can now work with it as a fraction. Cos A cos B divided by cos A will give us cos B. So you multiply cos B multiplied by sine A. Sine A cos B. You come here, divide by cos B, you are left with the cos A. You multiply cos A and sine B, which is here. This one now forms an identity of sine A plus B, and this one will be left like that. So we finally get this as our answer, guys. We go to the third. We have cos A all over sine B minus sine A all over cos B gives us that. So let's see what we will do. The first thing, guys, is that we can look for the LCM of sine cos A over sine B minus sine A over cos B. We work with it as a fraction. So look for the LCM of that. LCM of that is sine B cos B. You divide that by sine B, you are left with the cos B. So cos B cos A, it's here. You divide that one by cos B, you are left with sine B. Sine B multiplied by sine A, you get that. So that's what you get. And then guys, you can multiply both the numerator and the denominator by 2. So if you multiply, this is what you get. And the reason why you multiply is because when you multiply, this one now becomes an identity of sine 2b. Or the 2 will still be left there. This is now the identity of cos A plus B. So finally, you get your answer as that. We continue with another question here, which is 1 all over 1 minus sine theta minus 1 over 1 plus sine theta gives us that. So let's prove that identity. We still do the same, the fraction. We find the fraction for that, not the fraction but the LCM. That is the LCM. Divide by that, you get 1 plus sine theta minus this. This one was supposed to be 1 minus, but because of this minus, guys, we could have put a bracket first, but then I did not put the bracket, so I had to change this one to be plus. So you get that, and this one is the difference of two squares, which gives us the difference. This one gives us a difference of two squares. If you expand this and that, you will get that, of which this one, guys, is cos squared theta, and the numerator is 2 sine theta. So you are left with this, that is 2 sine theta over cos squared theta. One of the sine and cos will form a tan, and the other one will remain as cos. So finally, guys, you shall have this, that is 2 tan theta sec theta as your answer. So let's go to the next one. You prove this identity. This one, from the factor formula, the upper one will be formed by 2 sine b plus c over 2 cos b minus c over 2. Both of them will form what we call factor formula. Then you have this one for cos b minus cos c. So you can divide by 2 there, divide by 2. You are left with only negative. Can divide that and divide. This one will still be 1. This one is 1. So you are left with this, which is the reciprocal of tan. That gives us minus cot b minus c all over 2. We have still another question here. 1 minus sine theta all over 1 plus sine theta. You prove this identity is equals to that. So first thing, guys, is we find the conjugate of 1 plus sine theta, which is 1 minus sine theta. Multiply the denominator and the numerator. So when you multiply the numerator, you get 1 minus sine theta. This is theta. That is theta. Theta is there. 1 minus sine theta into bracket squared all over 1 minus sine squared theta. Because this one will, when you expand it, you get difference of two squares, of which this one, guys, is cos squared theta, as we have seen it here. Then this one then is equal to 1 minus sine theta to bracket squared all over cos squared. So I can now put them under the same bracket and write squared there. So this one now I can come and separate them. I separate 1 over cos theta minus sine theta over cos theta. So this one you shall get, the first one will get sec theta, second one will get tan theta, but this square still remains. So finally you shall have something like this, sec theta minus tan theta squared, like that, guys. Finally we come to the last identity we want to prove, and it says sine theta all over 1 plus cos theta plus 1 plus cos theta all over sine theta. Prove that it is 2 cosec theta. So we look for the LCM here. You divide by that, you get sine squared plus, you divide by sine, you get 1 plus cos theta multiplied by 1 plus cos theta. So the sines sine squared theta and cos squared theta is equals to 1. So 1 plus 1 is equals to 2. So you get 2 there, plus 2 cos theta all over this. So you can factor out the 2. So when you factor out the 2, you are left with this. And you have this as part of your denominator. So this one will cancel. You are left with the 2 sine theta, of which now you get 2 cosec theta. So guys, that is our revision for trigonometric identities. So guys, thank you for giving me your time. Bye bye.